Good day everyone, and welcome to where we are putting together solutions to those math and science problems that students are getting. In this video, we'll be looking at CSEC Mathematics, and specifically the topic of trigonometry, which occurs in section 2 of the paper. This video will look at the past paper questions from May 2014 until 2018. Feel free to like the video and add any comments down below, so we can help create other videos to assist you in whatever areas that you are struggling with. Don't forget to look at the description down below, where we have outlined the order we suggest to go through the entire CSEC Maths syllabus with all the solutions. Let's look at the 10 major topics in CSEC Mathematics, and in this video we'll be looking at topic number 8, geometry and trigonometry. This topic is tested for 8 questions out of the 60 in paper 1, multiple choice, and for 21 marks in paper 2, which is worth 2 full questions. This topic can be subdivided into 2 parts, into geometry or trigonometry. In this video, we'll be looking at trigonometry, so that itself can be subdivided into right angle triangles or any other triangle. Within right angle triangles, we specifically look at that diagram above, where we give the angle, the hypotenuse h, the opposite o, and the adjacent a. And the rules that relate them, we can relate the lengths of all 3 sides using Pythagoras' theorem, which states o squared plus a squared is equal to h squared. Or we can use trigonometric ratios, sine theta is equal to o over h, cos theta is equal to a over h, and tan theta is equal to o over a. Those 4 work for any right angle triangles. And for any triangles, whether they're right angle or not, we can use the sine rule. A over sine A is equal to B over sine B, which is equal to C over sine C. Or we can use the cosine rule. A squared is equal to B squared plus C squared minus 2BC cos A. Let's look at some basic steps we can follow if we're getting problems with this topic. When tackling this topic, the first thing we can do is list all formulae, which are 4 formulas for the right angle triangles and 2 more if it's considered for any other triangle. Then we identify which shape is relevant. We redraw only that shape, and then we identify which sides and angles the question uses, select the formula, substitute, and then solve. May 2014, number 10b. The diagram below, not drawn to scale, shows the positions of 3 ports, P, Q, and R. Q is 80 kilometers from P, so let's bring up the 80 kilometers. R is 100 kilometers from Q, so let's bring up the 100 kilometers. On a bearing of 66 degrees, and angle PQR is equal to 54 degrees. Calculate, part 1, the bearing of P from Q. So that means that we're standing at Q, facing a northerly direction, which is what our arrow has, and turning in a clockwise motion until we face P. So let's extract the diagram, and notice that what they're really asking us to find is angle NQP, which is angle NQR, that piece up on top, plus angle RQP. And angle NQP, we can substitute here. We know 54 degrees, that's given. And let's look back at the question above. It was said that R is on a bearing of 66 degrees from Q. So if we're standing at Q and turn until we face R, that angle we have in green, because we're moving in a clockwise direction, we're turning that way, is 66 degrees. So we can substitute for NQR to be 66, and therefore solve that angle NQP will be 120 degrees. Part 2. The bearing PR corrected 2 decimal places. So if we want to find PR, let's bring up a purple arrow there on the right hand side to show where that line is. And what do we know? we already know two other sides, so we have three sides involved and one angle. So that means we can use the cosine rule. And the cosine rule states a squared is equal to b squared plus c squared minus 2bc cos a. And when we're substituting for the cosine rule, we look at where the angle A is. The angle A is 54 degrees. That's at the corner Q. So let's replace this formula that we wrote by the letters according to this particular diagram. So A, which is the length opposite the angle of 54, is PR. So that's PR squared is equal to PQ squared plus QR squared. It doesn't matter which one you put for B and C. Minus 2 by PQ by QR by cos Q. Let's substitute values now. 80 squared plus 100 squared minus 2 times 80 times 100 cos 54. And we know 80 squared, 80 is 64, 6,400 plus 10,000 is 16,400. Minus 2 by 80 is 160 by 100 is 16,000 cos 54. And if we substitute that into our calculators, we will get PR squared to be 6,995. And if we want PR alone, we carry the square across. From the left-hand side, when we carry it across, it will do the inverse of square, which is square root. So the square root of 6,995 works out to be 83.636, and continuing. But if we look at our question up in part 2, it wanted our answer to 2 decimal places. So let's highlight the 3, because the 3 would be the second decimal place. So either we're going to keep our answer as 83.63 or we're going to increase it to 83.64. And what tells whether we keep it or increase? We look at the number to the right of 3. The number to the right of 3 is 6. So that's a large number. Therefore, it will become 83.64. May 2014, number 10b. Calculate, the last part of the question, part 3, the measure of angle QPR to the nearest degree. So let's extract the triangle and let's highlight angle QPR with a green arc and bring up what we know. We know 100 kilometers, which is the side opposite that angle. We already know 54 degrees. So do we know the side opposite that? Yes, we worked that out in part 2. And that was 83.64 kilometers. So we have two sides and they're two opposite angles. So we can use the sine rule in order to find the one unknown. Because the sine rule has 4 different terms, 2 sides and 2 angles, and we have 3 out of the 4 terms. So let's write the sine rule. P on sine P is equal to Q on sine Q. Let's recall that when we're writing the sides, it will be common letters. So there's a common P on top and a common Q on top. And when we're writing the angles are at corners, so they are capital P and capital Q. And if we want to find an angle, there are different ways to work it out. I will just get the reciprocal or flip both sides. So we get sine P over P, and we can replace the angle P by full name, which is QPR. So sine QPR over, what is the opposite to it? QR, which is equal to sine Q over PR. Now we can substitute values. Sine QPR over 100 is equal to sine 54 over 83.64. So if we want sine QPR alone, let's carry the 100 across. The 100 is dividing on the left-hand side. When we carry it across, it will multiply. It will end up in the numerator. So we'll get 100 times sine 54 all over 83.64. And we can use our calculators, and that works out to be 0.967. So if we want QPR alone, we have to remove the sine from the left-hand side. And when you carry across the trigonometric ratio sine, it becomes the inverse of it, sine inverse, or arc sine. And we'll get sine inverse 0.967, which works out to be 75.23 degrees. Is that our final answer? Let's look back at the question again. The question is asking us to find the angle QPR, which we've done, to the nearest degree, the nearest whole number. And as such, we have the 5 in our bold maroon again, and it indicates that either we keep it as 75 or we move it up to 76. And what tells us that? The number next to the 5 on the right of it, which is the 2. It's less than 5, so therefore we keep it as the same, so angle QPR is equal to 75 degrees. May 2015, number 10A. The diagram, not drawn to scale, shows a vertical tower BT, which we have shaded, with a flagpole TP mounted on it. A point R is on the same horizontal ground as B, such that RB is equal to 60 meters, and the angles of elevation of T and P from R are 35 degrees and 42 degrees, respectively. Part 1. Label the diagram to show the distance 60 meters. So let's look at our diagram, and we can see where B is, which is at the base of the tower, to R, and that is 60 meters. So let's bring it up. And the next part, the angles of 35 degrees and 42 degrees respectively. So if we look at on top, we can see that the question told us those angles are angles of elevation of T and P. So let's deal with the 35 degrees. It means that we're standing at R, looking horizontally or flat, which means we're looking at B, and we're turning our heads upwards until we see T. So that angle is the angle of elevation, which is 35 degrees. And if we're turning our head to deal with the 42 degrees, means we're turning even further to look up at P. Part 2. Calculate the length of the flagpole, and the flagpole will be from P to T, giving your answer to the nearest meter. Well, there are a couple ways to do this, and maybe the easiest way would be to look at the largest triangle PBR, which is a 90-degree triangle. So let's extract that. And what do we know? We know we have a 90 degrees. We know the base, which is 60 meters. And we know the angle of elevation, 42 degrees. So can we find PB, which is the opposite side of that angle? Well, we're dealing with opposite and adjacent. So that rule is tan theta. So let's write that. The formula, tan theta is equal to O over A, opposite over adjacent. And we can substitute what we know. Out of those three things, we know two of them. So tan 42 is equal to PB, PB is our opposite, over 60. So if we want to get PB alone, the 60 is dividing, we need to move it from the right-hand side. It's in the denominator. When we carry it across, it will multiply. So it will be 60 tan 42 is equal to PB. And using our calculators, that gives us 54.0 meters. Now that we know the whole length from P to B, can we get the height of that tower, TB? Well, we can look at the smaller triangle, TBR, and that is also a right angle triangle. So let's extract it. And it has a 90 degrees, the base is 60 meters, and the angle is 35 degrees. So we want to find TB, which is the opposite. It's similar working to what we just did because we have O and A. So tan theta is equal to O over A. Let's substitute tan 35 is equal to TB over 60. Carry the 60 across. So we're going to get 60 tan 35. Exactly the same sort of working as we did just now. And that gives us 42. Now we want to find the height of the flagpole, PT. And that will be PB, the entire length, minus TB, the height of the tower. 54 minus 42, that is 12.0. And let's look at our question again. They want our answer to the nearest meter, so we want a whole number. So that is 12 meters. May 2015, number 10B, the diagram, not drawn to scale, shows the relative positions of three fishing boats, K, L, and M. L is on a bearing of 40 degrees from K, and M is due south of L. LM equal to 120 kilometers and KL is 80 kilometers. Part 1. On the diagram, show the bearing of 40 degrees. If you recall from above, L is on a bearing of 40 degrees from K, means we must imagine that we're standing at K, facing north, along the dotted line. And we're turning in a clockwise direction until we face L. So that angle, let's bring it up in green, that angle there will be 40 degrees. Part 2. Calculate the measure of angle KLM. Let's look at that triangle and let's extract it. That's the parts that we need. And what do we recognize? Remember that we just got the 40 degrees, which is in green, as that angle. And we want to find KLM, that angle in purple. So what's the relationship between both of them? If we follow with this black line, we can see that there are two parallel lines and a transversal. As such, the angle in green and the angle in purple are alternate angles. And the theorem states alternate angles are equal. So, angle KLM is equal to angle NKL. So, angle KLM is equal to 40 degrees. And part 3, calculate the length of KM. So, if we look at the triangle on our right side, let's bring up KM and being indicated by a purple arrow. Now we have two sides and we want to find a third side, so let's use the cosine rule. Cosine rule states a squared is equal to b squared plus c squared minus 2bc cos a. Let's substitute km squared is equal to kl squared plus lm squared minus 2 times kl times lm times cos l. And that means, let's bring up that angle in purple. That will be our angle L, which we've just found to be 40 degrees from part 2. And let's substitute 80 squared plus 120 squared minus 2 times 80 times 120 cos 40. And we can work out the first part, 80 squared plus 120 squared, that's 6,400 plus 14,400, which is 20,800. Minus 2 times 80 times 120, that's 19,200 cos 40. And using our calculators, we can get that km squared is 6,092. As such, km is the square root of 6,092, which is 78 kilometers. May 2015, number 10b, part 4. Calculate the measure of angle LKM. So if we look at our diagram, there's only one triangle. Let's extract it. And we know 40 degrees, that's the one in purple. And we know that opposite the L of 40 degrees is 78 kilometers. We just worked that out in the last part. And what do we want to find? We want to find angle LKM. Let's bring that up in green. So we have two angles and two sides that are involved. Those four things indicate that we need to use sine rule. So let's write it. K on sine K is equal to L on sine L. And we want to find an angle. And there are different ways to do it. So I will just find the reciprocal or flip both sides. So sine K, but let's write K differently. It's the proper name, that angle is sine LKM. All over LM, the opposite of it, is sine L over KM. Let's substitute. Sine LKM over 120 is equal to sine 40 over 78. And if we want sine LKM alone on the left hand side, the 120 has to be removed. It's dividing on the left side, when we carry it across, it will multiply. So we'll get 120 times sine 40 all over 78. Let's use our calculator, and that will give us 0.9889. And if we want LKM, the angle, we need to remove the sign from the left-hand side, and when we carry it across, it will be inverse sine, or sine inverse, or arc sine. They all mean the same thing. So arc sine, 0.9889. So angle LKM, which is what we wanted to find in part 4, is 81 degrees. Now part 5, the last part of the question, calculate the bearing of M from K. So if we're considering M from K, it means that we're standing at K, facing north, so that's the NK line, and we're turning clockwise until we reach M. So we want to find that large angle there. So let's extract that triangle and bring it down. And since we want to find that large angle NKM, it is actually two smaller angles, angle NKL and angle LKM. And angle NKL is the bearing, which we have in green, and that is 40 degrees. And angle LKM is in purple, and we just worked that out in part 4, that is 81 degrees. So angle NKM, which is the bearing of M from K, is 121 degrees. May 2016, number 10b. The diagram below, not drawn to scale, shows two ships, R and S, at anchor on a lake of calm water. FT is a vertical tower. So we can see that there's a 90 degrees between the vertical tower FT and FSR. FSR is a straight line, and RS is equal to 150 meters. The angles of elevation of T, the top of the tower, from R and S are 22 degrees and 40 degrees respectively. And we can see that in the diagram. F is the foot of the tower. Calculate, giving your answer to one decimal place where appropriate. Part 1, the measure of angle RTS. In order to calculate RTS, the angle at T, we need to have the angle at R, which we do, and the angle at S, but we don't have that angle. So can we find it? If we extract that point S, what do we realize? That we have 40 degrees, and we need to find the angle in green. Now let's recall that supplementary angles add up to 180 degrees. And the angle in purple, which is 40 degrees, and the green angle will add up to 180. So let's write that. Angle FST plus angle RST is equal to angle FSR, this whole angle. So let's substitute. 40 degrees plus angle RST is equal to 180 degrees. If we want RST alone, we need to move the 40 degrees across, so we get 180 degrees minus 40 degrees. So angle RST is equal to 140 degrees. So let's bring it up in green in the diagram. Now that we know that, can we now find the angle T up on top, the angle RST? Well, let's extract the triangle. And we have the 22 degrees, and let's put in what we just found, the angle in green, which is 140 degrees. So we need to find the red angle up on top, angle T. And of course, the same rule applies that all three angles add up to 180 degrees. So angle T plus angle S plus angle R is equal to 180 degrees. And let's substitute angle T plus 140 degrees, which we found just now, plus 22 degrees, which is given, is equal to 180 degrees. So angle T plus 162 is equal to 180. So if you want to find angle T, we carry the 162 across, so it will be 180 degrees minus 162 degrees. And what's the proper name for angle T? RTS, which is what we want to find in part 1. So angle RTS is equal to 18 degrees. Part 2. Calculate, giving your answer to one decimal place where appropriate, the length of ST. So if we look at ST, how do we find that? Well, let's extract that triangle on the right side. And what do we realize? We have the angle 22 degrees and the angle 18 degrees, which we just found in part 1. So we have two angles, and we have a length of one side, 150 meters, And what do we want to find? Let's bring that up with the purple arrow indicating we want to find that length, ST. So we have two angles dealing with two sides, so that's sine rule. So r on sine r is equal to t on sine t. So let's substitute. R on sine 22 is equal to 150 on sine 18. And let's just recall something, that the angles sort of correlates with the length. So if we look at 18 degrees, opposite to that is 150 meters. And if we have 22 degrees, opposite to that, which is what we want to find, should be bigger than 150. So let's see if our working gives us that. So if we want to get rid of the sine 22 on the left-hand side, we need to carry it across and it will multiply. And what is r? Small r is really that length opposite of the angle, which is st. So st is equal to 150 times sine 22 all over sine 18. So st gives us 181.8 meters. May 2016, number 10b, part 3. Calculate, giving your answer to one decimal place where appropriate, the height of tower FT. So if we look at FT, that forms a right angle triangle FTS. So let's extract that. And what do we know? We know it's a right angle triangle. We know 40 degrees. And in the last part of the question, part 2, we found TS, which would be the hypotenuse, as 181.8 meters. So what are they asking us to find? FT, the opposite. So if we're dealing with a right angle triangle with the opposite and the hypotenuse, then that trigonometric ratio that we can use is sine theta is equal to O over H. And let's substitute. So sine 40 is equal to, what is the opposite? FT, which is what we want to find, all over 181.8. So if we want to find FT, which we have indicated with the purple arrow, that would be 181.8 times sine 40. Using our calculator, it gives us our final answer, which is 116.9 meters. May 2017, number 10b. A ship leaves port A and sails 52 kilometers on a bearing of 44 degrees to port B. The ship then changes course to sail to port C, 72 kilometers away, on a bearing of 105 degrees. Part 1. On the diagram, not drawn to scale, label the known distances traveled and the known angles. And if you look at our diagram and go back to the information on the first line, it said that the ship sailed from port A to port B 52 kilometers. So we can bring up the 52 kilometers to show the distance AB, and it was on a bearing of 44 degrees, meaning that when we stood at port A and we're looking north and we're turning clockwise direction of 44 degrees, then that is the bearing. So we can see that in green. And then the ship then changes course to port C. So that means it's going from B to C, which is 72 kilometers away. So BC is 72 kilometers. And on a bearing of 105 degrees, so we can do the same thing, showing from B facing north that when it turns, that the angle it turns is 105 degrees. Part 2. Determine the measure of angle ABC. So if we look at ABC, that triangle, and let's extract it, and what do we know? We know that bearing is 44 degrees, and from that, if we follow the black lines that we have, what can we tell? The green angle, 44 degrees, and the red angle, there's a relationship, and the relationship is that they are alternate angles. The theorem says alternate angles are equal. So that means that the red angle is also 44 degrees. And if we look at our north line at B, we have 105 degrees was the bearing above in green. So can we find what is in purple? Because that gives us a straight line. So that angle is 75 degrees. As such, angle BC will be the red angle 44 degrees plus the purple angle 75 degrees. So angle ABC, which is what we want to find, will be 119 degrees. Part 3. Calculate to the nearest kilometer the distance AC. So let's extract that triangle, and what do we know? We know 52 kilometers, AB we know 72 kilometers, BC, and we know 119 degrees, which we just worked out in part 2. So if we have two sides and one angle, and what do we want to find? AC. So let's show that by the purple arrow. So if we're dealing with three sides and an angle, that should be the cosine rule we'll have to use. So let's write that. A squared is equal to B squared plus C squared minus 2BC cos A. And cos A, or that angle, is 119 degrees. That is at the corner B. That is at B. So we can say AC squared is equal to AB squared plus BC squared minus 2AB BC cos ABC. And we can substitute. So we get 52 squared plus 72 squared minus 2 by 52 by 72 cos 119, which is equal to 7,888 minus 7,488 cos 119. If we put that into our calculators, we'll get 11,518. And AC will be the square root of that, square root of 11,518. So AC, that distance, is 107 kilometers. May 2017, number 10B, part 4. Show that the bearing of A from C, that means we're standing at C and facing north, and we want to turn in a clockwise direction. That red arc will show us how much we have to turn to face A. So show that that bearing is 260 degrees. So if we look at that, the whole angle at C is 360 degrees. We would like to find the red angle, which is the bearing. What we can do is find the other two parts and then subtract them from 360. So let's see if we can do that. So let's extract BC, and let's recall we have the 105 degrees already given as that bearing at B. And if you notice that the two lines facing upwards are north lines, meaning that they are parallel. So let's bring up this in black to indicate that if we have two parallel lines cut by a transversal, how can we relate that angle in green to the angle in purple? Well, the theorem states that interior angles, which these two are supplementary, meaning that if we add them up, we will get 180 degrees. And if the angle in green is 105 degrees, that means the angle in purple is 75 degrees. So we found that first part. Now, let's extract the triangle ABC so we can figure out the next angle that was missing, which is at C. Now when we extract it, let's bring up the things we know. We know AB is 52 kilometers, and that's opposite the angle at C, which is what we want to find. We know 107 kilometers AC, which we found previously, and the angle ABC is 119 degrees. So we have two angles and two sides. So the rule that normally relates this is the sine rule. So let's write that down. C on sine C is equal to B on sine B. And remember, the letters on top are written as common letters indicating the length of those opposite sides. And the angles are written as capital letters. And since we want to find the angle, there are multiple ways to do this. I will just reciprocate both sides or flip them. So we get sine C over small c, and small c is really AB. So sine C over AB is equal to sine B over AC. And we can substitute. Sine C over 52 is equal to sine 119 over 107. And what is sine C? Sine C is actually the angle ACB. Sine ACB is equal to 52 times sine 119 over 107, because if 52 is divided on the left side, and when we carry it across, it would multiply. Using our calculators, that will give us 0.425. And if we want the angle ACB alone, we can carry the sign across. And that will be the opposite of sine, which is sine inverse, or arc sine, or inverse sine, 0.425. And that, make sure our calculator is set in degrees and not radians or grad. That angle is 25 degrees. So we found the two small angles on the left. So now let's extract C. Let's pull up the small angle, 25 degrees, and the other angle, 75 degrees, the two that we just worked out, and the red angle. So what that means is 25 degrees plus 75 degrees plus angle C is equal to 360 degrees. Angle C here meaning the angle in red, which is the bearing that we want to find. So 100 degrees plus angle C is equal to 360. Angle C is equal to 360 minus 100, so angle C is equal to 260 degrees. And this is what we wanted to prove, so we could bring up a small rectangle or write QED to show that we have proven whatever the question asked. May 2018, number 9A. The diagram, not drawn to scale, shows the relative positions of three reservoirs, B, F, and G, all on level ground. The distance BF is equal to 32 kilometers, FG is equal to 55 kilometers, angle BFG is 103 degrees, and F is on a bearing of 42 degrees from B. And we can see all four pieces of information on the diagram. Part 1. Determine the bearing of B from F. So let's extract that. And what does the bearing of B from F mean? We're looking in a northern direction and we're turning according to that black line in a clockwise direction until we face F. So that can be subdivided into two parts. First of all, let's look at the purple arc. It means that we're turning from north to south. So that is 180 degrees. And then we're turning the remainder of that angle which is in red. So how can we determine that? Well, let's bring up these black lines. And what do we recognize? That we have two parallel lines. Those black lines are parallel, cut by a transversal. And how does the red angle compare to the green angle of 42 degrees? Well, they're both alternate angles. And what's the theorem? Alternate angles are equal. So that means the angle red is 42 degrees. So the total bearing of B from F would be 42 degrees, the angle in red, plus 180 degrees, the angle in purple, which gives us 222 degrees. Part 2. Calculate the distance BG, giving your answer to one decimal place. So if we extract that triangle, and let's bring up a purple arrow to show where BG is, what do we have? We're dealing with three sides, the 32 kilometers, the 55 kilometers, and what we want to find. And we have one angle, so three sides and an angle means we can use the cosine rule. Let's recall the cosine rule is a squared is equal to b squared plus c squared minus 2bc cos A. And cos A, that angle A, where is that? That is the 103 degrees, which is actually F. Let's rewrite it using these points. So A is bg squared is equal to bf squared plus fg squared minus 2 by bf by fg cos F. And we can substitute. That's going to give us 32 degrees plus 55 degrees minus 2 by 32 by 55 cos 103. And 32 squared plus 55 squared is equal to 4049 minus 2 by 32 by 55 is 3520 cos 103. So bg squared is equal to 4841. So if you want bg, that will be the square root of 4841. So we found bg, which was the distance. May 2018, number 9A, last part. Part 3. Calculate to the nearest degree the bearing of G from B. So if we're looking at G from B, then we're really catering for the point at B. So let's extract that. And when we're looking at a bearing, it means at B, we're looking in the north direction and we're turning in a clockwise direction until we face G. And we indicate that by a black arrow. And how do we get that entire angle? The bearing of G from B is equal to the angle NBF, which is what we have, plus angle FBG. So the bearing of G from B is equal to 42 degrees, which we have in green, plus that other angle FBG, which we need to find. So let's go back to the triangle FBG and let's extract it. And what do we also know? We know 69.6 kilometers. And what do we want to find? We want to find angle FBG. So let's put that as a purple arc. And if we have two sides and two angles, then we can use the sine rule. So B over sine B is equal to F over sine F. And we want to find an angle. So my method will be just to flip or reciprocate both sides. So sine B over B, and what's small b? That is FG, that distance, is equal to sine F over, and what's opposite to the angle F? The side BG. And let's substitute. Sine B over 55 is equal to sine 103 over 69.6. And if we want sine FBG alone on the left-hand side, let's carry the 55 across. It's dividing. When you carry it across, it will multiply. So we'll get 55 times sine 103 all over 69.6. Make sure your calculator is set in degrees. And your calculator should give us 0.770. And if you want FBG, that angle, then we need to get rid of the sine from the left-hand side. And when you carry it across, it will be sine inverse 0.770, which gives us 50 degrees. So we can now put that into the missing part of our equation. Bearing of G from B is equal to 42 degrees plus 50 degrees, which is 92 degrees, 092. We have now come to the end of CSEC past paper questions in the topic of trigonometry that occurs in the second section of paper 2. In our first video in this, we did past paper solutions from 2009 until 2013, and in this video we did the following 5 years from 2014 until 2018. Our next video will be from 2019 until the present. Don't forget to look at the description down below in order to follow the order we've suggested to cover the entire CSEC Maths syllabus, with solutions from May 2009 until the present.